This video will discuss Chapter 2-1 on pages 33 to 34, if-then statements and their converses. If-then statements are conditional statements, and they are sometimes called conditionals. They are written with the words if and then. For example, if it rains after school, then I will give you a ride home. If a plus 2 equals 9, then a is equal to 7. If-then statements are made up of a hypothesis and a conclusion. The hypothesis, or P, follows the word if. The conclusion, or letter Q, follows the word then. Can be written as if P, then Q. That is the shorthand. If the hypothesis, then the conclusion. If P, then Q. If it rains after school, then I will give you a ride home can be written as though P is the hypothesis, it rains after school, and Q is the conclusion, I will give you a ride home. In this example, if a plus 2 equals 9, a plus 2 equals 9 is considered my hypothesis, or P, and the conclusion is a is equal to 7. We also talk about the converse of if-then statements. The converse of a conditional statement is formed by interchanging the hypothesis and the conclusion. So the statement is if P then Q, and the converse is if Q then P. A statement and its converse say different things. Some converses are true and some are false. For example, if we have our statement, if 4x is equal to 20, then x is equal to 5, the converse of that statement is, if x is equal to 5, then 4x is equal to 20. This converse is true, because in this case, x can only be 5. In this case, this is one example that will work if x is 5. In this example, we have the statement, if Ed lives in Texas, then he lives south of Canada. The converse of that statement would be, if Ed lives south of Canada, then he lives in Texas. This is a false converse because we can find an example that proves this false. For example, Pennsylvania is south of Canada, but it's not Texas. So what if Ed lives in Pennsylvania? What if Ed lives in Connecticut? What if Ed lives in California? The examples that find these false are considered counterexamples. So a counterexample is an example that disproves a statement. It only takes one counterexample to disprove a statement, even if there are many examples that prove the statement true. If I come up with one counterexample, that means that the converse is false. A converse is only true if no counterexamples can be found. Not all conditional statements are written with the if clause first. Some examples are if P then Q, that is the example that we learned. We can also say that P implies Q, P only if Q is true, and Q if P. So in this case, the then comes before the if. For example, x squared is equal to 25, x can be negative 5 or positive 5. X squared equals 25 implies that x is less than 10. X squared equals 25 only if x is less than 10. And x is less than 10 if x squared is equal to 25. All of these are examples of conditional form. If a conditional and its converse are both true, they can be combined into a single statement using the words if and only if. A statement that contains the words if and only if is called a biconditional statement. It is called a biconditional statement because it will work forwards and backwards, meaning that there are two ways to write it. I would show this as P if and only if Q. Every definition can be written as a biconditional. which is what makes it a definition. So, for example, the definition that we learned, congruent segments are segments that have equal lengths, can be written in if-then format as segments are congruent if and only if their lengths are equal. The biconditional statement is how we usually see the definitions written in geometry. Why do we need to know this for the future? Every theorem that we will be using will be written as a conditional statement. If this set of circumstances is true, then this can be applied to it. Many theorems will also have converses that will need to be learned. You will find that we have a theorem and then the next section we learn about its converse. If you are familiar with the way these things are written, then we understand the concepts. Don't forget to bring any questions or concerns you may have to class.